Very good morning to one and all. So, in this session, let us discuss about the instruction set of 8085. Instructions are nothing but it is a command to the processor to perform a particular operation. Usually, system will understand everything in the form of binary. There should be a person who is going to transfer the human understandable to the machine. Okay, since we cannot directly remember all things in terms of binary, so we write our assembly language program using opcodes, which opcodes are hexadecimal. Okay, in microprocessor, the entire instruction set is being classified into 5 groups, which is data transfer group, where the instructions here is used to transfer the data between the registers or between the register and the memory. Next comes arithmetic groups. From the word is very clear, it is going to do arithmetic operations like addition, subtraction, increment and decrement. Then comes your logical group. There are 3 main logical operations which can be performed, which is nothing but AND, OR and XOR. Branch is nothing but from the main program I am going into any particular sub program, do the task and come back. This is usually done because in our main program some group of instruction or a particular task which has to be repeatedly done, so we will not include it in main program so that the program becomes very lengthy. Rather, we will write it in separate portion, and whenever we want we will use that particular program and come back. So that types of instruction will come under branch. Next is your input, output and mission control. To control the mission operation, there are some instruction which is being used that comes under input, output, mission control group. Okay, let us start the first type of data transfer. First type of group, which is nothing but data transfer groups. So now you are going to transfer the data from one location to another location. The first instruction, that is instruction number 1, is move from a register to a register. So please see that we have written it as move R1, R2. You have to be very clear. From the right hand side you are going into move to left hand side. So right side yours is source and left side is your destination. So from R2 value is being moved to R1. See, R is nothing but a general purpose, any general purpose register. So we have a general purpose register as A, B, C, D, E and HL, where A is the accumulator and remaining all are general purpose register. Now for an example, move A, B, the content of B register is being moved to A. The thing which we have to remember is here it is not cut operation, it is an copy operation. So once after execution of this instruction, content will be there in B as well as in A. Only B content is copied and pasted in A. Okay. Next comes a second type of data transfer, where it is an indirect way of doing it or addressing it. See, please listen, MOV R, M, where M is nothing but the program will go and see what is there in HL. HL will have an 88-bit, 16-bit. This 16-bit is taken as address. Go to that particular address. That address will have an 8-bit that is being moved to the register which is being specified. Here we are just putting it as R, whereas that is nothing but any general purpose register. Next one is MVI R, data. So wherever now if you see this person called I in an instruction, it is saying it is immediate. Immediate means within the instruction you have the data which is to be moved. So for an example, for this instruction, if you want, it is MVI A, 08, where 08 is data which is directly moved to accumulator. Okay, next one is also similar way. Only thing is data is moved to M, where M is nothing but you will go to HL, it will have a content, that content is taken as address. Go to that address and save this data. Now please listen again, LXI RP, data 16-bit. Wherever you see this X, which is saying that it is register pair, not as a register. So load register pair immediate which register pair you have to load is being specified here, and this is the address. So what happens is, lower order of your data of 16-bit will be moved to the lower order register pair location, and then from higher order will be moved. For let us see an example. If it is LXI H, 4500, 00 will be moved to L, 45 will be moved to H. That is this particular instruction. Next it is LDA address. See here, L is for load, D is for direct, A is for accumulator. So I am directly specifying the address. From that address, move the 8-bit content to the accumulator. Only 8-bit can be moved. Please remember, the address is 16-bit. So you have to go to that location, take it the 8-bit data, and that is being moved to accumulator. Similar to the load, there is an instruction to store. This is STA address. So the content of A is being moved to the address. Previously we have seen the content of the address is moved to A. Now the content of A is being moved to the address specified. Then L, H, L, D direct. So here I am L is same load, H is D is same direct, whereas HL, instead of loading accumulator, here you are loading HL. So you will have an address. That address value is being moved to this L register, increment by 1, move to this particular H register. Now let us see the next instruction, that is SHLD, store the content of HL to the address. Again please listen, address will be 16-bit, whereas that location can hold only 8-bit. Now this is 16-bit data is there. So what we'll do is, the first it will move the content of L to the address specified by the programmer. Then address will be automatically incremented by 1, and then H content will be moved there. Okay, I repeat, SHLD, store the HL content direct to the address specified. The address specified address is a 16-bit. That 16-bit address can hold a value of 8-bit. So when you, for an example, if it is SHLD 4500, L value will be moved to 4500. Then address will be incremented by 1 to the next location. H content value will be loaded. Then LDARP. Then from the register pair which you have told is taken as address, that is content of the register pair is taken as address. Go to that address, it will have an 8-bit value that is being moved to accumulator. Then comes a instruction called exchange, XCHG, exchange the content of H to D, L to E, that is called as exchange. Similarly, E content will be moved to L and D content will be moved to H. In other words, it is like a swap. Next to your data transfer instruction, we have arithmetic instruction. Arithmetic in 8085 is done by a simple way of full adder. So if with the help of full adder, what and all I can do is, I can do addition. By 2's complement method, I can do subtraction. So that is also an addition. Then I can do increment. Then decrement I can do. Then multiplication and division is possible by doing repeated addition and repeated subtraction. So instruction under arithmetics are ADDR. Please listen. If there is no C in the instruction, then addition without carry is being performed. So R can be any value like any general purpose register. Please listen, before doing any arithmetic instruction, one content should be in accumulator. Okay, so you might have already loaded some value in the accumulator. That accumulator value will be added with the register specified, and the result will be stored in accumulator itself. It is again indirect way to get the data. We go to HL. HL will have a value, take it as address. That address will have an 8-bit that is being added with the accumulator. Now this tool 12 and 13, they are not involved with carry. Instruction 14 and 15, it is same as instruction 12 and 13. Instead of not taking carry here, we will include carry also. Next is ADI data. Please listen here. ADI, immediate data, is there in the instruction. This immediate data is added with accumulator. You don't confuse that. Here data is there, another data should be in accumulator. Both the data is added and result is again stored in accumulator. So this is without carry, your immediate adding is there. This is immediate adding with carry is been done. So a, new a is nothing but a plus the data in the instruction plus carry. So that is we have seen. Now let us see the instruction number 18. Please note it separately. Even they can ask you, tell an instruction, tell an arithmetic instruction where accumulator is not involved. That is this particular instruction. For this particular instruction, HL is taken as accumulator. So this is a 16-bit addition instruction where one content should be in HL, another content can be from any register pair. Any register pair is nothing but we have only other two more register pair, which is BC or DE. So the content of BC will be added with HL, or content of DE will be added with HL, and the thing is the result will be stored in HL. So it is similar to your accumulator. For this instruction alone, HL is your accumulator. Okay. And then again you have subtract R. Again please listen. If another B is not there, borrow is not been done. So this is SUBR without borrow they are saying. So accumulator, new accumulator is accumulator minus R. Similarly, this is an indirect way. Again A is minused with the address. The content in HL is taken as address. Go to that address, bring that particular data that is being subtracted. Now here what you have seen is SUB, this is SBB. Then subtract with the borrow. See, please listen, this is a flaw in case of 8085. No subtraction can be done without using borrow. So this too should be ruled out. With the borrow only we can do. So with borrow, similarly with register, with the memory, with the immediate data. So this is immediate data without using borrow. This is with using borrow instruction. So what I have already been told you that in arithmetic operation you can do addition and subtraction. Next is you can do increment and decrement. Increment the register means the content of the register will be incremented by 1. Let us assume if INR B and B holds a value 8, then after this INR R or INR B, the content of B will be incremented by 1. It becomes 9. Similar way it is an indirect way. So HL will be taken as HL content will be taken as address. Go to that address and value will be there. That value is incremented by 1. Similar to the increment instruction, we have the increment instruction. Increment the register, decrement the content of the HL specifying location. Next comes INX RP. Please listen. Wherever you see this pattern called X, it says that instruction is involving with register pair. So INX, you have to increment the register pair. Register pair incrementing is usually it will start from lower order. Once the lower order get overflow, then move to the higher order. So in INRX will increment the register pair with the lower order by 1. Please listen. I have made a mistake here. This is a plus sign. I have put a minus sign. Please consider. I am sorry. This should be plus. Next is decrement. Decrement the content specified in the register pair by 1. Okay. ADD is a decimal adjust. Then let us move on to the next group, which is logical group. See, everything what has been done in logic in case of 80 is done in Boolean operation. That is, each and every bit of the particular content is done your logical operations. Okay, all flags will be get affected in your logical groups. I have not told, even in your arithmetic groups flags will be involved. In data transfer instruction there won't be any flags involved. Okay, so flags are involved only in arithmetic and logical. So there are 3 logical operations which can be performed in case of 8085. It is AND, OR and XOR. AND is between a register and the accumulator. See, one content should be an accumulator, another content can be any register value. If again by register, you can even do by indirect, or you can do by using a data. So immediate data can be AND, a data from HL taking as an address, go to that address, take the data, that is been ANDed. Okay, similar AND operation, there is OR operation is also possible. The only difference between AND and OR is, and if both the bits have 1, result will be 1, otherwise it will be 0 in case of AND, whereas in OR, if any one bit is 1, result will be 1. Next to R is XR. XR is also done by three ways. One is with the help of register and accumulator, with the M and accumulator, with the immediate data present in your instruction. Let's move on to the instruction number 41, which is CMA, that is complement the accumulator. So if the accumulator has a value, that will be complemented. I will tell you an example. If accumulator has FF, once you take complement of FF, the result is 0 0, because FF all bit are 1. If you complement all bits become 0, so it will become 0 0. Okay. Next one is complement the carry status. Only this carry status, it is being complemented. If carry status is 1, it will become 0. If it is 0, it will become 1. Okay. Next instruction is STC, which is set the carry status. Please listen here. If the carry is 1, it will become 0, and if the carry is 1, it will become 0, and 0 and 1. So that is toggling. This is not toggling, this is just setting. If it is 1, even if you put set carry status, it will become 1. If it is 0 and if you use this instruction, it will become 1. Okay. Then compare register with the accumulator. Now what you are going to do is, we will compare a register value with the accumulator value. This is from the register we will take the value. This is by indirect way we will take the value, and this is by directly data in your instruction is compared with your accumulator. So next let us see about rotations, various type of rotating instruction. That is, you can rotate it by left your 8-bit, or you can rotate right of your 8-bit. 8-bit is nothing but the 8-bit value in your accumulator. So rotate left. See, there is again a flaw in 8085, that is the notation they have wrongly done. Please see here, RLC, you should not confuse that it is rotating left with the carry. Without carry means there will be a C. If you are involving with the carry, then C is absent. So this they might have wrongly used. If they put the C here, then it will be very easy to remember that rotate with the carry and rotate without carry, but that is not there here. So when you see RLC, rotate L without carry. RRC is rotate right without carry. Okay. So what happens is, bit 7 will become to bit 0, bit 6 will move to bit 7, and this how it is rotated in leftwise, and this is rotated in rightwise. Okay, same operation with involving carry. So carry will come to 0th bit, here carry will come to a 7th bit. Now let us move on to branch control groups. I have already told why we want to have a branch. There is something which is repeatedly has to be done, which will not be repeatedly included in the main program. It will be usually written separately. Whenever you want, you go to that place, do the work and come back. See, there is a difference between jump and call. There is two types of jumping instruction or branching instruction. When you do by jump, you will write it as JMP followed by address. So program counter once sees this instruction, the next value of the program counter will be moved to stack, whereas in case of jump it will not be moved. So it will just load this address to the program counter and it will proceed. Okay, there is something called unconditional and conditional. In unconditional, I will not see any conditional. Directly I will jump to the address specified. In conditional, I will check for condition. Only if that condition satisfy, I will move. So we will see what and all the conditions which are available. Jump on 0. If 0 is set, then only it will jump, or it will come to the next line. Similarly, jump if there is no 0, jump if there is carry, jump if there is no carry, jump if it is a positive number, jump if it is a negative number, jump if the parity is even, jump if the parity is odd. So all this will check for the condition, and only if the condition pass, it will move to the new address or to the next line of the program. Call. The difference between jump and call, whereas in case of jump, there is no mandatory that you have to come back. Whereas in case of call, you will call an address, go to that address, do the work and then come back. So we will come back with an help of written instruction. So when you use call followed by an address, the program counter will have the value. For see, let example less. In line number 5000, you write the instruction call 6000. What happens is 5001 of the program counter will be moved to stack. then the new address will be loaded to the program counter, and then it proceeds. Again, when he sees the return instruction from the stack, it will bring it to the program counter. So again 5001 will be brought back to the program counter and your program execution will continue. That is the difference between jump and call. Then comes your stack, input, output and machine control groups. See, there can be an 8-bit address. So that 8-bit address will have a value, and from that value if you want to bring in a value, then you use an instruction called in. Similarly, value should be moved to an 8-bit address, we use out. Now please listen, there is a special instruction called push and pop. Push, you are pushing something to some location. Pop, you are bringing it out, like popcorn coming out of the machine. Okay, so push RP, why you want to have this person? See, I have a general purpose register saying B, C, D, H and L. I have already used all the registers in my program, and if I want some more register, what can I do? I have to store this current register value to a location, then use the register, then again bring back the value of the old content to the register. So that can be done with the help of push RP. If you write push B, content of B register and C register will be pushed to stack. Now you can use your BC register for some other purpose. Again, to get back the old value, I will do it with the help of pop. Please listen, only you should know which value is pushed first and which value has to be popped out. System doesn't know. So if you push B, then if you push D, first you have to pop D, then you have to pop your B. Okay, that machine will not know, only you have to identify. See, the last kept plate can be taken first, not the plate which is being kept at the bottom. If you take, it will collapse. Similarly, first if you have pushed BC, then if you have pushed DE, then if you have pushed HL, take the HL first, followed by D, then followed by B. Okay. Next is DI, which is disable interrupts. Interrupts are nothing from interrupting my work from external. If I don't want anybody to interrupt me, then what I will do, I will use an instruction called DI, disable interrupt. And see, if I not disabled, I have enabled it. But for an example, if I am taking a class by closing the doors, so that the outside person cannot disturb me, but he will constantly be waiting. That can be done which is similar to the mask. I am putting a cover over an interrupt and I am not showing the interrupt to the my 8085. So my 8085 will proceed. At an instant, what can I do? I can see to all and all person I have asked to wait. That is run by read interrupt mask, and set interrupt mask is to which person will come and I will ask him to wait. So I can set which interrupts to be made to wait, and I can read what and all interrupts are waiting now. NOP is a special instruction where executing this instruction no operation will be carried out. Only it is of that usage of clock pulse without using for any other purpose. Okay. Next is when you can even push your stack pointer. This is, we call it as program status word. So when you are doing a particular thing, some flags are affected. I want to use it for some other purpose, or I want to record it. What can I do is I can push the flag content. Similarly, I can pop it out, my program status word. Alt is the final line of your program, indicating the processor that program has come to end. When you use this alt, then next line will not be executed. It is come to understand that your program has stopped. Next is exchange stack top with HL. Now this is a special instruction where last kept value can be brought to HL register directly. Similarly, move the content of HL pair to the stack pointer. This is taking a plate from a plate which is being displayed in stack. This is putting a new plate. So here HL content will be moved to stack. Okay, this can also be done. The same work can be done using a push instruction. When you write push H, the content of HL will be moved to stack, and there is a special instruction for the HL itself, that is move HL content to the stack pointer by putting SPHL. See, I have told you disable interrupts. I can even enable. In some program, my program wants the interrupt to interrupt my process if there is something going wrong. In that case, I will make the interrupt to be enabled and then I will proceed. So with this, we will conclude that this is about the various instructions available in your 8085. Thank you.